After the 100 plays, how much money do you have? Do you win? Do you lose? How much do you win? How much do you lose? What's your bank at the end? Okay. Some people maybe have an answer? Yeah? So what do we think the answer could be for this? 50 euros. Yeah? So how did you get 50? Yeah, go on, why don't you tell me?
You can have 50 times you get the heat.
That's it. That's the key thing. So after 100 turns, how many times should heads show up? 50 you would think, about. And how many times will tails show up? 50. So if you get heads 50 times, that would be 100 euros. And if you get tails 50 times, it means you lose 50 euros. So in total, are you winning or losing? Yeah, you're winning by 50 euros. Now this is the thing. Will it always be 50 euros every time you do this? No, because you won't always get 50 heads and 50 tails. So we need it, yeah?
In the difference, like, the coin you get 100 times, so you multiply half by half by half.
Oh, we won't get to the actual calculation like that. That's something we'll do later, yeah. But my idea is if you flip the coin 100 times, maybe you get 51 heads and 49 tails, you know, because it's random. It's by chance. You would be very lucky if that happened, but it's possible, yeah. So, we don't use the word, it's not right to use the word average. Don't worry, it'll come up. Oh, my screen is just blocking it a little bit. There we go. It's not right to use this word. Why not? Why is it not really right to use mean average or average? This is wrong. Well, when do you use average? What do you need to use average? Well, what I'm thinking is you need to have data. Do you have any data? No, you don't, because you're talking about the future. You're imagining what will happen in the future and what your situation will be. So we don't use the word average. We use this word instead, expectation. And we usually write it like an E. So if I wrote expectation of your money, this is what you expect to win or lose. Does that make sense? Yeah. So remember we said we flip the coin 100 times and we expect to make 50 euros. So each time we flip, how much are we increasing what we expect to get? So in other words, when I flip it once, I should get 50 cents. Now can I get 50 cents? No, I can only get 2 or minus 1. So this, what did I say? Plus 2 or minus 1 is what I expect to get. What I could get. But if we play this 100 times, we'll get 50 euros. That means each time we play, we're getting it's like we're getting 50 cents. But of course, you understand that each time I play the game, I don't always get 50 cents. I never get 50 cents. Sometimes I get 2, sometimes I get a 1. So this expected value, it's like how much the flip is worth. You know, it's worth 50 cents to you, because each time you flip it, you are producing an extra 50 cents. Okay? But of course you understand that you don't actually get 50 cents each time. This is just like it's like an average. So we need an exact way to calculate expected value. So the way we think about it like this is if we have a table, and let's say here's our probability, so we'll just do P1, P2, P3, etc. And then we can have X, and we could have X1, X2, X3. So in my previous game, I had a 50% chance of winning 2, and I had a 50% chance of losing 1. The expected value per play, per turn, you add up all the outcomes multiplied by their probabilities. So in the example I'm talking about with the coin, it will be €2 times 0.5 plus minus €1 times 0.5. So that would be 1 minus 0.5, so that would be 0.5 euros. So each time we play, our expectation has gone up by 50 cents. So this is the idea behind expectation. Okay, do we get the idea?
What's the 50?
50 cent here. That's a euro symbol.
Yeah, what does it mean?
This is each time we flip the coin, we expect to get 50 cent. But you realise we don't really get 50 cent because there's only 2 choices, 1 or 2. This is why I keep saying it's like getting 50 cent. If you do it 100 times, it makes more sense. 100 times you expect to get 50 euros, and 1,000 times you expect to get 500 euros. So 1 time we expect to get 50 cent. What about 10 times? If I play this game 10 times, what should I expect to win? 5 euros. Yeah? So let's have a look. So here's Stephen's coin tossing game. So we play it 100 times. Okay, so we need a probability. Well, no, what's it? Random, isn't it? Yeah. So if this number is less than 0.5, we'll say win 2, otherwise lose 1. Okay. Great. Let's go down to 100. Right, so I've just imagined the game here. Let's hide this out here. And then this is what I win or lose. So the first time I flipped the coin, what happened? I won 2 euros. Then the second time I won 2 euros, and the next time I lost a euro. So let's have a look at what my average, my moving average is doing. So first time I play, okay, I just get 2 euros and that's it. Second time, 2 and 2. So what's my average here? 2. I'm still averaging 2 per turn. So it's actually going very well for me. Okay, now I know each time I press enter it's going to change because it's random.
Wait,
Huh? It's changed because each time I press enter. So let me just put all the values in so it doesn't change again. Okay, now it won't change. Right, so you can see here, when this time I play the game, I lose and then I win. So after 3 turns my average is 0. And then after 4 turns I'm losing 25 cents. But if you continue playing this game, notice towards the end, on average per turn I've won 44 cents, which is close to what we were imagining a moment ago, where each turn is worth 50 cents. What happens if I play this game more? Will the average become closer to 50 cents or further away? I think the more you play it, the more it should even out. So if I go play this game 1,000 times, oh no, that's quite bad. Something went very wrong here.
Very lucky.
No, nobody's that lucky.
Oh.
No. Something went wrong after here, I think.
No, you weren't lucky.
No, nobody's that lucky.
Very lucky.
That's you.
Yeah, okay, maybe me then. Oh, it's so not right.
Oh,
So the key thing is to play 1,000 times.
I don't know what. Yeah, what's? Oh, I know what's wrong. I know what's wrong. Show. I forgot to copy down the one I hid. This is why I was winning €2 all the time. Show columns. There we go. This is the. All right, now we fixed it. Okay, that's still good. 60 cents. So I was pretty lucky this time. I played 1,000 times. So I'm actually averaging 60 cents per turn. That's how much it's worth to me. Okay, so this is the idea behind expectation. You just take the outcomes and you multiply it by the probabilities. This gives you how much you expect to win or lose. Okay, so I'll give you a small game to try, and then you give me the answer. So for this game, we have a wheel. Let's make the wheel have 4 equal parts. What? It's beautiful. All right. So in this game, you spin the wheel, and if it lands here, let's say you win €1. Here you win nothing. Here you win €2. And here you win €5. Hey. But
How many times?
just one. So to play this game, you have to pay €1. So what I want you to do is to first just make the table, put the probabilities, and then your money situation at the end of the game, which we'll call X. So the first step, I want everyone to make this table for me. There are 4 outcomes.
They all have the same chance of coming.
Yes, they do, yes. You pay €1 to play this game. Just one. Okay, have you made the table? Well, the probabilities are easy. It's just going to be 1/4, actually my table is upside down, but who cares? 1/4, 1/4, 1/4. Right, so the first outcome, what's your money situation here? If it lands here, what's your X? Your 0. Because you played 1 to win 1, your situation is 0. In the next quarter, -1. And the next quarter, 1. And then in the last quarter, you're up €4. Okay, so I want a calculation for per turn, per spin, what's your expected gain or loss?
3?
Is it 3? So let's calculate it. It's 0 times a quarter minus 1 times a quarter plus 1 times a quarter.
How -1?
This value is -1
Yeah.
in this one.
Wow.
Yeah, this one here. This is 0, -1, 1 and 4. Where was it? The last one. Plus,
And the 2.
what 2?
You forgot the 2.
Oh, I didn't forget any 2. So, I see, right here, yeah. So you had to pay €1. So if you pay €1 and you win €2, what's your money situation? You're only up €1 because you have to pay €1. Your profit is only €1. You had to pay €1. You got back €2. So you're only up €1. Like Malik. In the first one you had to pay €1, and how much did you win? €1. So if I give you €1 and you give me €1 back, cancel, 0 for the first one. Okay.
Can you create the probability for all the 4, like 2 and 0, 1 and 5, and get -1 at
Should be the same answer, yes.
so it will be 1.
Well, let's going to calculate it. Yes, 1. Yeah, 1.
Yeah.
€1. The -1 here, is it? It's because this outcome is worth -1 to you. The value of it is -1. If you prefer Remul, it's like plus -1. Yeah. The outcome 0, -1, 1 and 4. Actually, I should have maybe written that the other way around. Not that it's wrong, but we'll keep it the same. It'd be better. So the last one is 4 times 1/4. So each turn is worth €1 to you. Yeah. So is this a good game or a bad game for you? It's a good game for you. No, it's a good game for you because each turn is worth €1 to you. So if you play this game 100 times, what should be your money situation? You should be up €100. This game is bad for the person who is running the game because each time you win and gain €1, what happens to them? They lose €1. So this game is not fair. So this gives us the next idea of what's called a fair game. So a fair game is when, that's it, yeah, when the expectation is equal to 0. So this means that I don't expect to make or lose money and the other person doesn't expect to make or lose money.
So it's not always that will be 0.
What's that?
Will not always that will be 0. They like.
Will this always be 0?
No, not always that this person that is playing will get like 0.
Oh no, the whole reason the person is running the game is probably because your expected value should be less than 0. That each time you play you should lose money so that he gains money.
But like in casinos?
In casinos it's definitely this. I promise you, yes. It's definitely that in casinos, yes. And actually, this should be quite negative as well, I think. So this is the idea for a fair game, that you expect to win or lose 0. Okay. How many? Who's been to a casino? Anybody? Nobody? Oh, come on, I don't believe that. There has to be at least one person here. You can't all be that good.
No.
Do you know that game where you drop the ball in the wheel and it's red and black and red and black? Roulette. You know this game? How many numbers are on this game? 36. You see, I knew somebody would know. Okay.
And a 0.
And a 0. And the 0 is very important. So 36 plus 0. And the 0 is very, very important. So, the way this game works, we'll look at this one next. So you have 18 red, 18 black, and then there's one of them which is a 0. So what you have to do is you have to guess if you think it will be red or black. It's like when you flip a coin, you have to guess if it will be heads or tails. So if you guess correctly, you double your money. So if you put down €5 and you say it's red, and it's red, you get €10. But of course, if it's black, then you lose all your €5. So if we think about this game, there's actually 3 outcomes. Oh, that's an ugly table.
What's the 0?
And oh, don't worry, the very special one. We'll get to that. Now, let's do. This is x, and this is probability. No, I have it upside down again. I'd like my. No, yes. Which do I like on the top? I think I like the x on the top. All right, x here. So you bet €1. So if you guess correctly, what happens to your €1? It becomes €2. But if you guess wrongly, then you lose your €1. Sorry, no, not €2. Sorry, you gain €1. If you guess incorrectly, you lose €1. So minus €1.
You said it's double the money you pay.
Yeah, sorry. So I give you €1, and if I win, you give me back €2. So I get back my original €1, but I've gained an extra €1. So yeah, this is the gain, not the total amount. Yeah. Okay. So you have an 18/37 chance of guessing correctly, and 18/37 chance of guessing wrongly. What happens if it lands on a 0? Does anyone know? Nothing. If it lands on a 0, it doesn't matter if you said red or black, you lose, regardless. So a 0 means you always lose. Now that's not too bad, that's 1/37.
But you can bet the 0.
You can't. So 0 is everybody loses. Everybody loses. So if you bet red and I bet black, and it becomes 0, then the casino takes my money and it takes your money. So this is the best outcome for the casino. All the money on the table is taken by them. Okay, so let's calculate. No, I'll let you calculate now the expected value here.
No, the casino is like both game money from like 18/27. The black and the 0.
No, well, think about this. It gains money every time you guess wrongly, and the 0, yeah. So this one here is if you guess right. This is if you guess wrong. Oops. And this is if it shows a 0.
Yeah.
Yeah, so they make money if you guess wrongly or a 0 comes up. Yeah.
So how is it fair?
It's not fair. This is because Victor was talking about casinos. I wanted to do this one to show you it's not fair. Yeah. So what's the expected value? Have we calculated? It'll be minus 1/37. Yeah, because it'll be 18/37 times 1 plus 18/37 times minus 1 plus 1/37 times minus 1. So the answer is, what's that? 0 minus, can you give it to me as a decimal? 0.027? So it's like 3 cents then.
So it's almost fair.
It's almost fair, yes. But can you see why it was important for the casino to have this in it? Because if the casino didn't have this part here would be gone, and then the total will be 0, which would make it fair. So this game is not fair.
We always choose €1.
No, I just used €1 as an example, yeah.
But if I choose like €10, it will be different.
Yeah, you're right. If you choose €10, then this number gets multiplied by 10. In my casino is very cheap. You can only play this game by using €1 coins. Okay, it makes it easier. Yeah, no 100. The bank can't afford this.
So,
Now,
so it's actually like not real to calculate the expectation, because
no, if you want to think about it like this, Victor, it's €0.03 loss per €1 bet. So if you put down €10, you're expecting to lose 30 cents. Now the reason I do this example is because, in fact, this is the best game you can play in the casino. That's the bad news. So the best game you can play in the casino is you expect to lose 3 cents per euro. This is your best game.
I think if you pay more, like the gain will be more or less than 0. Like it will be.
If you pay more to play this,
Yeah.
you only make it worse. So if you if you pay 10 euros, you lose 30 cents, and for 100 euros, you should lose 3 cents. Yeah. So you're right. This game is almost fair, but there's no fair games in the casino. This is the game that's nearly fair. Okay.
Is there any techniques to this game?
This one, no. This game's not too bad. I mean, 3 cents per euro is not too bad. I know what some people do. Or maybe I shouldn't tell you this. But what some people do is, if you want free drinks in the casino, so a lot of casinos will give you free drinks as you play. So you have 2 people playing at the game, and this person always bets on red, and this person always bets on black. So this person bets €1, and this person bets €1. So if the game shows red, he will get back €2, and he will get 0. He doesn't get any money back. But it doesn't matter, because the extra money he got, he can give it to his friend. And if it was the other outcome, the extra money he got, he can give it back. So as long as they don't get 0-0, they can keep playing this game, which means they can keep getting free drinks then. That's the best you can do, I'm afraid. But there's a 1 in 37 chance that it will land 0-0, and then they both lose their money, no more free drinks. Yeah. I know this because one of the casinos in Dublin gives you free drinks as you play, and some people do this. What? No, I've not been to the casino actually. Yeah.
But I think all the casinos are like this.
Free drinks? I think most casinos are.
In Las Vegas is different.
I don't know about Las Vegas. I think you'd have to be betting more than €1 to.
Yeah, I think that's.
Maybe if you're betting per 100 euros, you might get a free drink. Maybe. Okay, so we have expectation, and the next thing we need to have a look at is something called variance. So I want you to calculate the expected value for these 2 games. So here, x, p, probability and x. It's upside down again, doesn't matter. Probability and x. So for this game, you could win 10 euros, or you could lose €1. And we'll put the probability here, I don't know, we'll make this probability 0.5, and this one here 0.5, for example. Okay, so that would be, okay. Right, so there's 2 games here. I want you to calculate the expected value for each game. Okay, what did you get for the first one? 4.5. 450. And for the second game? 450. So both games you expect to win 450, but if you look at both games, there is one game you should prefer to play, or maybe not actually. Well, it depends on your taste, I suppose. So what's the difference in the second game? Yeah, never lose. You always win 450. Guaranteed. In this game though, half the time you win 10 euros, but half the time you lose 1 euro. And maybe you don't like taking this chance. Maybe you prefer to be safe. But it doesn't really matter because both times you expect to win 450. If you play this game 100 times, how much should you win here? Well, you should definitely win 450. And how much here? Also 450, if you play it 100 times. So expectation is not enough. We need another way to measure how extreme the different outcomes could be. So if you think about a game where you could win €1 million, but you have a very, very, very small chance of winning €1 million. The expected value is quite small, but the difference between the top prize and the bottom prize is huge.
National lottery?
National lottery, yeah. So like most of the time you win 0, but some of the time you could win €1 million. Whereas if you play a small game with your friend where you flip a coin to win €1 or not, the spread is not so big. So do you remember in statistics we had a word for how spread out the data is? Do you remember what that is? Standard deviation. So we need a similar idea for these games, and it's called variance. And the formula is very similar. So do you remember for standard deviation you had sigma squared is the average of x squared minus average of x squared. Remember this?
Mm-hmm.
And this gives you sigma squared. In fact, it's almost the same for variance. The variance of x, this is like sigma squared, is equal to the expected value of x squared minus the expected value of x then squared. So you can see the similarities in the formula. So if you want to multiply that out, it would be the sum of pi xi squared minus the sum pi xi squared. Got this formula?
And what it means?
So it does mean like standard deviation, or rather, if you square root it, it's like the standard deviation. It's how spread out the outcomes are for you. So a big variance means your possibilities of winning and losing, they're very far apart. A small variance means that your difference between your winnings and your losings, they're not as far apart, they're closer together. Okay, so if you look back at this, oh no, it's gone up here. If we go back to this game, this one here, in fact, the variance is 0. There's only one possibility, that's it. Whereas here, I don't know, the variance will not be 0, it will be bigger than 0, because there's a big difference between winning €10 and losing €1. So let's calculate and see what we get. So let's do it for the first game. Okay, so we have x, what did I say, 10 and minus 1, wasn't it? And the probability was a half and a half. And the x squared will be 100 and minus 10. So variance of x will be 100. Well, if I write the formula down to help you.
How is it minus 4? What past 10? Is it 1? What?
Sorry, that's terrible. Minus 1 squared is 1, not 10. Mm-hmm. Right, thank you. Variance of x will be expected value of x squared minus expected value of x squared there. That will be a half times 100 plus a half times 1. Now I haven't worked out the expected value yet, so that's a half times 10. Oh no, you did it already. What was it? 450, wasn't it?
Yes.
Yeah, 450. Okay, can you type this in and tell me what you get? So variance of x equals, well, it'll be 50.546 minus, oh, it's squared, yeah. What is it, 49?
No, now I'm...
Okay. What do we get?
29.5.
39?
Yeah, 3.25.
Oh, what is it? 30 point?
25.
Okay. Sorry, Victor. 30.25. Yeah. So, Victor, you asked me how to interpret this, okay? So the interpretation, if you wanted, you have more interpretation with the square root. So the square root of the variance, what's that? It's about 5.6?
5.5.
5.5. So this is how you interpret it. When you play this game, on average you expect to gain €4.50. But of course you realise that doesn't happen every time. So every time you win some and then sometimes you lose some. So your possibilities are kind of spread out, where maybe you can win some more or you can win some less. So this is less and this is more. So that 550, it's a bit like standard deviation. It can swing left and right. So if you think about it, it's like saying, okay, so sometimes you can win more than 450. You could win like, it looks like, what's that, about 11, is it? And sometimes you can lose more than 450. 450 minus 550 is minus 1. So you can win about 11, you can win about 10, and you can lose about minus 1. And if you look back at the game, kind of represents what we have, isn't it? Like you could win 10 or lose 1. So the square root of the variance, it's a way of putting kind of limits on your possibilities of what could happen. So if you were playing a game, and this game could be investing in a company. So from business, how do you invest in a company? What do you do?
Buy shares.
You buy shares, don't you? So you can think about buying shares as like buying tickets to play a game. So if you buy €10 of shares, maybe these shares go up in value and pay dividends. Or maybe the company goes bankrupt and you're left with 0. Either way, you want your expected value to be positive, negative, or 0. You want it to be positive. But what about the variance? Yeah, you would like the variance to be nearly 0. To limit the extremes of a lot of winning and a lot of losing. You want a small variance. Oh, and by the way, because variance has a square in it, the variance is always positive. It can't be negative because it measures a spread. So this is if you want to invest. You want this to be big and you want this to be small. Yeah. So some people, although this is getting a little bit more advanced for next year, but it is something you will do if you do business, economics and other things like this. You want to make this big, and what about this one? Minus V. So if you want to make V small, what about minus V? You want to make it big. So you can actually put the two together.
You don't want to lose too much.
No, the V is how spread out the data is, the game is. So you want V to be small.
Yes.
But I'm saying minus V, then you would want it to be big. If I just change the sign, that's all. So when you actually do investment, you do some kind of investment stuff with Mark and Donald, do you? You know what an investment is, don't you? Yeah. So when you do investments, what you're trying to do is to make this as big as possible. You're trying to make this as big as you can. Because if this is big, it means this part is big and the V part is small. which is actually what you want. Yeah. So this is called investment or portfolio. Do you know this word? Portfolio? Portfolio means like investment. So it's investment theory. But this is a tiny bit too advanced for us, so we will stop at that part there. Okay. So I give you some questions to practice, and then we'll do the next worksheet in a few minutes. Again, this was made last night at 1 a.m., so if you see mistakes, just let me know. You can try these for a few minutes. One, two, three, 4, 5, 6.
What we study in economics is different. Like,
You need one? Okay. Thank you for Albert. No, this is exactly the stuff you do in economics, microeconomics. Except the only difference is instead of games and casinos, it's stocks, bonds, investments. That's the only difference.
like it's the quantity demand is fixed, like the total.
Huh?
If some companies
you can start them now.
or firms increase the price, others will lose customers.
Oh yeah. That's getting more complicated for us then. I'm just talking about for today with economics buying shares. I think about buying shares as like playing a game. You pay some money, you get a ticket, maybe you win, maybe you lose. Gets much more complicated though. And this is what you would do when you study economics at university. Yeah.